Hi guys. Today we're going to take a look at pages 12 and 13 of the Unit 2 Classwork packet. So we're going to take a look at how to perform rotations. Now, a rotation is technically a tilt. Let me say that again. A rotation is a tilt around a fixed point called the center of rotation. The figure rotates at a specific angle, so like 90, 180, 270, and a fixed distance from the center of rotation. Let me say that again. The figure rotates at a specific angle and a fixed distance from the center of rotation. Even though figures can rotate about any point, right? Like this one over here or that one over there, normally they rotate around the origin, also known as 0, 0. Now rotations, they're rigid motion transformations because when you rotate something, you don't actually change it. You just change its orientation, right? Like if, for example, this marker right here, oh my gosh, I just rotated it. Did the marker change? Did it grow? Did it shrink? Not that I'm aware of. So it would be a rigid motion transformation. Now there are 3 coordinate rules that you need to know to perform rotations. These must be memorized. Let me say that again. These 3 coordinate rules must be memorized. Let me try that a third time. These coordinate rules must be memorized, which means highlight them, star them, put a big frowny face by them, do whatever you need to do, but you got to have these committed to memory, okay? And here they are. For 90 degrees, the formula is negative y comma x. For 180 degrees, it's negative x, negative y. And for 270 degrees, it's y comma negative x. Now, something I do want to say here, whenever you're given something like this, like a 90-degree rotation, unless the problem says otherwise, it's understood to be counterclockwise. Let me say that again. Unless the problem says otherwise, it's understood to be a counterclockwise rotation. What does counterclockwise mean? Well, think about which way a clock goes. You just go the other way. Okay, so you could think about it kind of like as going to the left. The same way that when you name your quadrants, right? You have quadrant 1, but then you have 2, 3, 4. You draw the C. C stands for counterclockwise. All right? So with no further ado, let's take a look together at example number 1, shall we? Now, you guys, I'm going to recommend that you actually take a minute, pause me, and graph those coordinates. Okay? And for this one, I'll actually do it with you. Why not? But for the rest, I'm going to trust that you have the ability to graph, and I will help you out with the coordinate rules. Okay? All right, so we got 2, 7. We got 6, 5, 4, 5, 6. Meh. And we got 4, 1. Meh. Meh. Alrighty. So, in order to perform a 90-degree counterclockwise rotation, the first thing I'm going to do is I'm actually going to write out all my original coordinates. Alright? So I'm going to write them out in a list, just like this. Pause me for a second or put me on mute or do whatever you need to do. I will try not to be too offended. And write down your list of coordinates. Okay? Now, the next thing we're going to do is we are going to write our coordinate rule. And in this case, our coordinate rule is negative y comma x. Okay, so let's think for a moment about what that means. That means that our coordinates are going to switch places. Let me say that again. Our coordinates are going to switch places, but whatever used to be the y value is going to change sign. Let me say that again because that's a little confusing, I know. Our 2 coordinates are going to switch places, but then whatever used to be the y value is going to change sign. So let's take a look at how that's going to work, okay? So all these y values are now going to come first, but if they were all positive, now they're all going to be, you guessed it, negative. And then I just put the x coordinate second. Let me walk through that one more time because I know that was a little confusing. The formula says negative y comma x. that means that my coordinates are switching places. So these switch places, but whatever ends up in this new first position, so this entire y column switches sign. And because all of them were positive, now they're all going to be negative. So if I want, I can actually go ahead and graph the transformed figure. 6, 7, all right, 2, -5, 1, 2, 3, 4, 5, 5, and then -1, 4, 1, 2, 3, 9. Okay, so notice it rotated. All right, this particular figure rotated 90 degrees. Now, like I said, it would be really, really hard to do this without the coordinate rule. So the key for these problems is memorizing your coordinate rules and being able to apply them. Let's take a look at an easier example, example 2, to see how this can be done with the 180 degrees. Okay? Now, we're going to start this problem off the same way as we did before. We are going to start by just making a list of my points. So, here we go. This is example 2, in case I forgot to say that. So I have 2, 6, I have 6, 5, I have 5, 1, and I have 1, 2. Right? Okay, step 2. Let's write out our coordinate rule, which is why is my marker almost dying? -x, -y. Okay, now this one's super easy because there's no switching. All I do is change all the signs. So guess what? If every single thing here is positive, what do you think is going to happen? Oh my gosh. Every number is simply going to turn negative. Oh my goodness gracious. I can't believe these problems can actually be that easy. Can you? No, of course not. Okay. Now, let's take a look at the following page. So now we're on page 13, and we're going to take a look at question number, let's look at number 3, just to get practice with the 270 so you guys can see how it works, okay? Alrighty. So, these problems, like I said, they're all pretty much the same. Like, you're going to write your list, you write your rule, and you just find the new coordinates. But what can get tricky sometimes is figuring out what to switch the sign of and what not to. All right, so let's take a look. So this one, they gave us 3, 4. They gave us 6, 4. Well, they were on example 3, just in case. And 8, 1, and 1, 1. And they asked me to do a 270-degree counterclockwise rotation. Step 1, voila, write the points. Step 2, let me write my coordinate rule, which according to the list right here is given by y, -x. Okay, so what exactly does this mean? This means that my coordinates are going to switch places. Let me say that again. The coordinates are going to switch places, but this time it's going to be whatever used to be first, they're all going to change their signs. So let's see how that's going to work, okay? So this entire y column, I'm just going to rewrite first, right? I'm just moving the y's forward. Easy peasy. Now, the entire x column is going to move to the right. So if these are all positive, what do you think is going to happen to them? They're going to become negative. All right? Now, I will say this. By far the most common mistake that I see is people mistake the 90 and the 270 degrees. They get things backwards, they mix up the formulas. So I would personally advise you that those are the two you should focus on memorizing your coordinate rule and make sure you practice, okay? Because that's where everybody always trips up. Now, the only time that things can get a little bit dicey is when instead they give you clockwise, right? Now, if you take a look, for example, at example number, oh gosh, I guess the number's cut off. Well, it's right underneath example 9, okay? It should actually be example, I guess, 11, but I guess the numbering got cut off, and I apologize for that. But it says 90 degrees clockwise. Here's a secret. Clockwise can be converted to counterclockwise. And it can be converted very easily because if I go on a full circle, how many degrees are there? So in a full circle, there are 360 degrees, right? So that means that 90 degrees counterclockwise is actually the same thing as going 270 degrees in the other direction. 180 counterclockwise is the same thing as 180 in the other direction, clockwise. And 270 counterclockwise is the same thing as 90 clockwise. So in this case, for 90 clockwise, what I would do is I would say, so if I go 90 degrees this way, that's the same thing as going 270 degrees counterclockwise. So for this particular problem, if it says 90 clockwise, you would use the formula for 270. Similarly, take a look at the last one on the bottom right. It says 270 clockwise. Okay, so 270 clockwise is going to get me like here, but that's the same thing as going 90 counter. So in the case of the last question, I would use the 90 degree counterclockwise formula. In sum, what's the most important thing to know here? These three rules. Of the three, the 180 is the easier, right? Simply because all you got to do is just change the sign of all of them, no switching. The 90 and the 270 are the ones that get people tripped up. I would really, really strongly suggest committing those to memory and focus on completing as much practice as you can. Make sure that you take a look at those on the homework. And if you have any questions, let's discuss it together.